Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 12.5, Problem 11. This is Section 12.5, Problem number 11. It says, find the derivative of f of x equals the natural log of 5x over x plus 3. So this function is like most of the others that we've seen in this homework section, where the function is the natural log of some stuff. And the derivative of a function like that is f prime of x equals, you make a fraction, in the top of the fraction you have stuff prime, and in the denominator the stuff just the way it is with no prime. Now you may have noticed that this function, the stuff, is a quotient. The top of the quotient, the 5x, will be the u. The denominator, the x plus 3, will be the v. And when we do the derivative of something like that, when I fill in the stuff prime portion of my stuff prime over stuff, it's going to be vu prime minus uv prime over v squared. That's how we're going to do the stuff prime with this. So f prime of x equals, let's put the stuff in the bottom first because it's just easier. The stuff is 5x over x plus 3. This is going to be what you call a complex fraction. It's going to be a fraction where the top is a fraction and the bottom is a fraction. So now the stuff prime, let me fill in vu prime minus uv prime over v squared. That's going to be the stuff prime. So v no prime. V with no prime is x plus 3. U prime, so u is 5x, u prime is just 5. Again, the 5x has a derivative of 5 because it's just an x to the first power. Its derivative is whatever the number in front is. Then I have minus. Then u with no prime is 5x. And then times v prime. So v prime, the derivative is just 1. Because the x plus 3 is the v, so v prime, the derivative of 1x to the first is just 1. It's the number in front of the x. The 3, since it has no x, its derivative is 0. And then you have v squared in the denominator, so v is x plus 3, and it'll be raised to the second power. So that is the answer, and at this point you could put in a value for x, but it can be simplified quite a bit. So f prime of x equals, again, I'll put in the denominator first just because it's much easier. 5x over x plus 3. Now, on top, I still have in the denominator of the upper fraction x plus 3 in parentheses second power. So let me clear the parentheses with x plus 3 times 5. 5 times x is 5x. 5 times 3 is 15. And then negative 5x times 1 is negative 5x. And you have positive 5x, negative 5x, they'll cancel. So we can simplify this to 15 over x plus 3, the second power, over 5x over x plus 3, just to the first power. So that's better. We can make it simpler still. Remember, when you have a fraction over a fraction, the rule was to invert or flip the lower fraction and multiply it times the top fraction. So this will be equal to the top fraction, 15 over x plus 3 in parentheses raised to the second power, times the bottom fraction inverted, so the 5x will go to the denominator, and the x plus 3 will come to the numerator. So now x plus 3 in the numerator and x plus 3 to the second power in the denominator will reduce. The 5 and the 15 will reduce. 5 goes into 5 once. 5 goes into 15 3 times. So we are left with, on top, just 3. And underneath, we have x plus 3 times x. So x plus 3 times x times x is x squared. X times 3 is 3x. And you cannot cancel the 3 on top and the 3 with the 3x because there's a plus in between. So that's the answer. That's f prime of x, which is a lot simpler than our unsimplified version that we started with. Now that method works, but if you remember your properties of logs, there's a much simpler way to come up with the same answer. So let's start with f of x equals natural log of 5x over x plus 3. So we just solved this problem by using the quotient rule, and it worked, and there was some simplification. We got it to a reasonably simple answer. Now, if you remember your properties of logs, you could say, oh, this is the log of a quotient. I can split that into 2 separate logs, and the same function can be written as natural log of the top portion of my quotient, so natural log of 5x, because it's a quotient, minus the natural log of the bottom part of the quotient. Do the derivative of this. So instead of doing one tough derivative, you can split it, make 2 simple derivatives. So f prime of x equals, so again, log of 5x, you're going to do stuff prime over stuff. The stuff is 5x, the stuff prime is 5. Again, the derivative of 5x is just 5 because it's next to the first. Then minus the natural log of x plus 3. So the x plus 3 will go in the denominator as the stuff. The stuff prime is 1. Now, I can simplify this a little bit. So first of all, the 5 over the 5x, let's cancel the 5. So I'll have f prime of x is 1 over x minus 1 over x plus 3. This looks a little bit different than our previous answer, but if you made a common denominator and put it over one denominator, it would come out the same. And this is much easier. So if you remember your properties of logs, you save yourself a lot of work. If you don't remember it, it's not a big deal. You can still find the answer, but it's easier if you remember your properties of logs.